Hello, good morning to all of you. Let us continue the chapter Sound and Physics. Today's date is 12th August 2020. In the last class, we had completed the numericals on echo, and I had also given you some assignments that to be solved from the textbook, some remaining numericals, and also you were supposed to do the difference, the uses of the echo. Now today we are going to start a new topic on the sound, that is called the vibration. Okay, now vibration is nothing but it is the periodic to and fro motion of a body when the body is clamped at one end or it is clamped at both the ends. Like for example, if I take this marker or pen, suppose this is clamped at this end and you apply the force here, so the body will move in the to and fro motion. Another example is the pendulum of a clock. It is moving from one extreme end to another extreme end. Likewise, we also have a string of the guitar. Okay, most of you play guitar. When you plug the string, it moves in a to and fro motion. So that is basically the vibrations of a body. Now in your topic in this class, there are three types of vibrations which you are going to study. Number one is the natural vibration. Okay, and number two is damped vibration. And number three is your forced vibration. So we are going to study in detail each vibration, the natural, or it is also called the free vibration. What happens is, in the natural vibration, basically what is the natural vibration? It is the periodic vibration of a body in the absence of any external force on it. That is called the natural or free vibration. So your key point you have to keep in mind that there is absence of external force. Now in practice it is not possible to have no force in the medium. Like for example, we have air now here. In the air there is some external factor always present, external force. What happens is, this vibration of a body, basically it takes place or it occurs in vacuum. Vacuum is a space where not even air is present. So some of the note you have to keep in mind here in case of natural vibration. The first point, it is said that it is the periodic vibration of a body in the absence of the external force. So number point one, absence of external factor. That means we can say that in vacuum. Second point is that since there is no any external force to disturb the motion of the body's two term, that is the frequency and the amplitude, remains constant. Frequency and amplitude remains constant. So these are the two key points in the natural vibration. In practice, it is very difficult to realize the natural vibrations because we cannot create we have to create a vacuum in order to have the natural vibration, or in the presence of any medium there will obviously be some external force or external factor. Now this natural vibration can be also represented in the form of graph known as the displacement time graph, and that is very important. So let us see that. displacement time graph of a natural vibrations. So let me draw one graph here. I am doing it with freehand. You need to do it with a pencil and a ruler. This horizontal line or the x-axis represent the time factor, the timeline, and this vertical line represents the displacement starting from negative to the positive. Since we have noted that in the natural vibrations, its amplitude remains constant. So therefore, I will make two marking here at the same height from the origin. Let us draw another from the origin. Now, like this it goes on. Now, what do we observe from this graph is the amplitude of the waves produced is constant. That means with the given time there is no decrease of amplitude. Why there is no decrease of amplitude? Due to the absence of any external force acting on the body, or the vibration is taking place in vacuum. So this is very important graph. You need to practice this. It is given in textbook. You have to draw it there also. Now we have the examples. There are many examples. If you turn to your textbook, you will find in page number 153 examples in page number 153 and 154. You will find that there are about 5 or 6 examples. I am just going to give you one example. Basically, these examples are, in practice, it is not possible because there is always presence of some external force. The tuning fork, we must have seen the tuning fork. It is like this. It is made up of some metal. Okay. Mostly it is made up of steel, and you take one hard rubber pad like this, and you strike the tuning fork. Suppose this is one of the arm. Then what happens is when you strike it and bring it close to your ears, you hear some kind of sound. It is created by the vibration. So that vibration which is produced by the tuning fork is the natural vibration, provided there is no external force. But in practice, external force is present. Okay, so like that you can learn at least 3 examples of natural vibrations from the textbook. Please refer to page number 153 and 154. Thank you. Now we will go to the second type of vibration, which is called the damped vibrations. Basically, damped vibration and natural vibration are both same. Only difference is that in the damped vibration there is a presence of this resistive force. Okay, now write down second one, damped vibration. Damped vibration is the periodic vibrations of a body in the presence of a resistive force. Note that word, in the presence of resistive force, and its amplitude decreases with given time. So that is the 2 key points in the damped vibration. The vibration of a body in the presence, P-R-E-S-E-N-C, in the presence of resistive force or external factor, then its amplitude decreases with time. These are the two key points that you have to keep in damped vibrations. Alright, now in addition to that, in the damped vibration you find that when the body is vibrating in the medium, in any medium, there is always the resistive force there. So there will be two forces acting on the body when in the damped vibration. So let us write down the second point. Two forces act on the body. The first one is called the restoring force. Now this is the force with which the body will start to vibrate. Then you have the resisting force. Now this resisting force is the force provided by the surroundings in the body or surroundings of the body. And that resistive force will decrease the amplitude, and slowly with given time the body comes to a standstill. So these are the two forces that is acting on a body when it is producing a damped vibration. And this damped vibration you can produce in practice, in a practical day-to-day life also. Examples, there are very simple examples of there. Now most of you must have plucked or tried to pull the branches of a tree while playing or while going home, etc. When you pull the branch of the tree and release it, what happens? You will see there is a vibration of the branches taking place, and if you stay there and observe for some time, the vibration, the movement of that branch will stop. And that is the example of the damped vibrations. Okay, now damped vibration also has the displacement time graph, so I'm going to show you that. Okay, now let us see the displacement time graph of a damped vibration. We have the same sort of diagram there. The x-axis will give you the timeline, the time factor. This is the origin, this is the negative, and this is the positive. A gives you the amplitude. This is the displacement, and all of you know that amplitude is the maximum distance made by the wave. So let us start from this point and let it come here. This is a rough sketch. Please refer to the textbook and make a neat diagram in your exercise copy. Okay, now what happens here is, this is obvious. Look, if you compare with the first one, natural vibrations, it was moving along the parallel line. The amplitude was remaining constant, but here with the time amplitude is decreasing and finally it comes to 0. That means the body will stop vibrating. Okay, so now these are the two vibrations we have discussed. Natural, also known as free vibration. Damped, the second type of vibration. Now what you do is, I'll give you one small assignments. Please all of you do this assignment from the textbook. Number one is, write 3 differences. Write 3 differences between natural and damped vibration, and for that you can refer to the textbook in page number 156. Examples, you can give one example for the natural vibration and one example for the damped vibration. Okay, now in the next class I will be continuing the third vibration, which is called the forced vibration. From the forced vibration you get the term resonance. Thank you very much.